So if you have ever spent, maybe 3 days tracking down why your ROC application just keeps timing out, you know the pain of the black box.
Oh, absolutely. The dreaded black box.
Right. It is honestly like trying to fix a complex car engine with the hood just completely welded shut. You can hear it misfiring in there. You know it is burning way too much gas.
Or, well, tokens in our case.
Exactly, tokens. But you literally cannot look inside to see what is failing. So today, for our deep dive mission, we are grabbing a blowtorch.
I love that. We are looking directly at Notebook 3 from the Microsoft Agent Framework, version 1.1.0, and our entire focus here is observability.
Because when you are deploying these autonomous AI agents, a welded hood is just a massive liability.
It really is. I mean, if an agent hallucinates a response or, say, hangs for 15 seconds on a simple prompt, you can't just guess the problem based on the exhaust fumes.
Right, you need diagnostic logs that expose the exact internal logic.
Exactly. Otherwise, you simply cannot debug it.
So we basically need to build an X-ray machine. And the framework does this by hooking up the Azure Monitor OpenTelemetry exporter package to Azure Application Insights.
Right.
But, how does that pipeline actually function under the hood?
Well, think of OpenTelemetry as a sort of universal adapter.
Oh, like instead of writing custom logging code for every single different LOM or database you use.
Right, exactly. OpenTelemetry standardizes all that telemetry data into a common format. So your Python code emits these standard signals, the exporter catches them, and then pipes them directly into Azure Application Insights or Grafana.
Giving you a literal millisecond by millisecond trace of the agent's execution path.
Yep.
But, okay, when I actually looked at what gets piped through by default, it is heavily redacted. Like, the framework's architecture defaults to extreme privacy.
Yeah, it does.
It captures the metadata, timestamps, latency, token consumption, but it deliberately strips out the actual text of the prompts and the responses.
Well, it really has to. Leaking sensitive user data into your diagnostic logs is a massive compliance failure. The system forces you to explicitly activate content recording via a specific Gen AI environment variable if you actually want to see the payloads.
Right. Azure tracing Jenny content recording tendable. But I have to push back on that design choice, honestly.
Oh.
How come? Well, explicitly turning on payload logging feels like a massive security liability just waiting to happen. If a developer flips that environment variable to true while debugging locally and then forgets to turn it off before pushing to production.
You are suddenly storing every single user's private conversation in plain text.
Exactly. Why even build in a toggle that dangerous?
See, that friction is actually a security feature. By forcing an explicit environment-level opt-in, it structurally separates your development environment from your production environment.
Oh, I see.
Yeah, you turn it on locally to deep debug the logic, but the default state is what protects you in production. It essentially forces your DevOps team to be highly intentional about data governance during deployment.
Okay, that makes sense. So, assuming DevOps configured the environments correctly and we are safely debugging locally, we can actually watch an agent think in real time.
We can. And to demonstrate this, the notebook spins up a financial advisor agent and asks it to break down the tax differences between the UK and the US.
Right, and the agent successfully navigates the nuances, distinguishing the UK's payee system and the April-to-April tax year from the US IRS calendar year.
Exactly. But what is critical here isn't the tax advice itself, it is how we observe the operation. The logging happens asynchronously.
Which means what, exactly, for the application's performance?
It means the telemetry batching doesn't block the main execution thread.
Oh, wow.
Yeah, the agent isn't sitting there waiting for the logger to finish writing to the database before it answers the user. It just fires off the logs in the background, keeping latency near zero.
And the visual output of that asynchronous logging in Grafana or Azure Monitor is this incredibly detailed waterfall visualization. It breaks the data down into what telemetry calls spans.
Right. The parent span represents the user's initial request.
And then cascading down from that, you see child spans for the specific LM calls and even separate child spans for any external cool executions the agent triggered.
Yes.
It is basically like a highly itemized grocery receipt showing exactly which microstep is burning through your token budget.
That is a great way to put it. It is like looking at a flame graph for CPU profiling, but mapped directly to AI reasoning. Instead of a single monolithic timeout error, you can see that, hey, the LLM call took 200 milliseconds, but the database query for the user's tax records took 14 seconds.
You isolate the bottleneck instantly.
Instantly. And the most remarkable part of this architecture is the implementation. You activate this entire diagnostic suite with literally a single line of Python.
Right, just calling configure Azure Monitor with enable live metrics set to true.
Exactly. It is the bridge that gives engineering teams the confidence to take agents out of sandbox testing and into real-world production.
One line of code to just rip the welded hood completely off. And, it makes you wonder about the next step.
What do you mean?
Well, if observability creates a perfect millisecond by millisecond record of an AI's internal thought process and resource consumption, could this massive repository of telemetry metadata eventually be fed back into the AI itself?
Oh, like a self-reflective agent?
All
The
right.
AI analyzing its own child spans and token usage to autonomously optimize its logic and debug its own bottlenecks.
Exactly. A machine that learns how to tune its own engine from the inside out. Definitely something for you to think about the next time you are staring at a timeout error.